Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.44 from the book Thermodynamics in Engineering Approach by CENGEL 9th edition. So, the statement of the problem is water means that working fluid is water. So, we will use steam table. It means that in given data, working fluid is water. Working fluid is equal to water at initially at 200 kilopascal and 300 degree centigrade. So initial pressure P1 is equal to 200 kilopascal and T1 is equal to 300 degree centigrade. Is contained in a piston cylinder device fitted with stops. Fitted with stops means that, let's suppose this is piston cylinder arrangement. In piston cylinder arrangement, at some position stops are fixed. Let's suppose here stops fitted with stop. These are stops. It means that if we compress the piston, it will not cross this area. It will fix here. Now this is the piston cylinder arrangement. Initial pressure and temperature are given to us, and here some stops are fixed. The water is allowed to cool at constant pressure. At constant pressure means P1 is equal to P2. And cooling the piston will be compressed. In cooling the piston will be compressed. The water is allowed to cool at constant pressure until it exists at a saturated vapor. It means that after compression the water or the steam or the vapor or the working fluid will be saturated vapor. And the piston rests on the stops. After cooling, piston will be here. After cooling, piston will be rest on the stop. This is the final position of this. Now if we further cool the system, it will not cross this area. It will, because here are stoppers. So this is V1. Total volume is initially V1. Here the volume is V2. After compression, the working fluid will be saturated vapor and the piston rests on the stop. It means that we cannot further decrease the pressure volume. Then the water continue to cool under the. Now we are cooling the system, but we cannot decrease the volume because here are stopper. So if we further cool the system, we cannot decrease the volume. So after this, pressure will be decreased. So P3, this is P3. P3 is equal to 100 kilopascal. And V2 is equal to V3 because V2 is the intermediate state. V1 is the initial state, V2 is the intermediate state, and V3 is the final state. But V2 is equal to V3 because here are stopper. So at V1 we cool the system and it will be compressed and rest on the stopper. So on the stopper the volume is V2. But if we further cool the system, volume cannot be decreased further. So V2 is equal to V3 and final pressure is 100 kilopascal. On the TV diagram sketch with respect to the saturation line. It means that draw the process on TV diagram. Sketch with respect to saturation the process curve passing through the initial, intermediate and final. There are three states. In initial state P1 or T1, intermediate state P2, T2, V2, Final state P2, P3, T3, V3. Label the T, P and V value for each in state on the process curve. Find the overall change in between the initial and final state. Find U2 minus U1, specific internal energy. These are the required values. Now, first we draw it on TV diagram. Temperature and degree centigrade and pressure, TV, volume and meter cube per kg. This is the saturation curve. This is saturated liquid line. This is saturation vapor. Initial pressure is P1 is equal to P2 is equal to 200 kilopascals. Let's suppose this is the constant pressure line on PV diagram. P1 is equal to P2 is equal to 200 kilopascal, and this is P3 is less than 200. This is 100 kilopascal. So this is P3 is equal to 100 kilopascal. So initial point and intermediate point will be on the saturated on the high pressure line 200 kilopascal, and this is P3, so point 3 will be on this line. So first we find point 1. So at point 1 pressure and temperature are given to us. So first we check whether point 1 is in mixed region or in superheated region. So from saturated steam table at pressure P1 is equal to 200 kilopascal, saturation temperature is equal to 120.23 degrees centigrade. So, and the temperature given to us is 300. ST1 is greater than TS. 300 is greater than 120.33. So point 1 will be in superheated region. So point 1 will be in superheated region. This is a 200 kilopascal. Saturation temperature is 120.23 degrees centigrade. This is in degrees centigrade. So from this point to this point temperature is 120 point, but temperature given to us is 300 degrees centigrade. So this is the constant temperature line, and here temperature T1 is equal to 300 degrees centigrade. This is T1. So this is T1 is equal to 300 and point 1. This is point 1, which is in superheated region. Now we check point 2. So at point 2 we know that it is saturated vapor. Until it exists as saturated vapor. So it means that point 2 will be unsaturated vapor line. So at intermediate state, the working fluid is saturated vapor. So the working fluid is saturated vapor. So point 2 will be unsaturated vapor line. Saturated vapor line. And pressure is 200 kilopascal, so this is point 2. And at point 2 we know that temperature T2 or Ts is equal to 120.33, because here the temperature is saturated temperature, and saturated temperature is 120.23. Now we know that from 2 to 3 volume is constant, because here are stopper. here are stoppers, so piston cannot move further, so V2 is equal to V3. So this will be a constant vertical line. This is, and here this is V2 is equal to V3, and here this is V1, this is V1, and V2 is equal to V3. This is point number 3, and point 3 is in mixed region because this is straight vertical line, and in cooling the temperature is decreases, so it means that point 3 will be temperature and pressure also decreases, and this is constant pressure line of 100 kilopascal. So it means that the point 3 will be in the wet region. So this is point 1, this is point 2, and this is point 3. So this is the TV diagram, and pressure and temperature are known here. So now we have to find U2 minus U1. First, this is the TV diagram, and now we have to find U2 minus U1. So U1 is in superheated region, so we will use superheated steam table. So for U1, this is the required value, U3 minus U1, sorry, because final state is the U3. For U1 we will use superheated steam table. So from superheated steam table, at pressure P1 is equal to 200 kilopascal and temperature T1 is equal to 300 degrees centigrade. Find U1, and you can also find V1. So check superheated steam table. So this is superheated vapor table, this is superheated, and here this is 200 kilopascal pressure, and this temperature is 300 degrees centigrade. So here this is temperature line, and this is pressure 200 kilopascal, and this is specific volume V, and this is internal energy. So in front of 300 and below specific volume at 200 kilopascal, specific volume is 1.31616 meter cube per kg, and U1 is equal to, this is U1, 2808.55 kilojoule per kg. So here you can write here V1 is equal to 1.3161 meter cube per kg. Here this is meter cube per kg. So V1 is equal to 1.3161. Now we have to find U2. For U2, first we find V2. So because with the help of V2 and V3 we will find X3, and with the help of X3 we will find U3. This is U3 basically. So we know that V2 is equal to Vg. Because this is on the supersaturated vapor line. So from saturated steam table at pressure P2 is equal to 200 kilopascal, V2 is equal to Vg. So at 200 kilopascal, find, this is saturated steam table, this is 200 kilopascal, and this is V2 is equal to Vg, 0.88573 meter cube per kg, and we know that V2 is equal to V3 from the given, which is equal to 0.88573 meter cube per kg. Now here you can write this, V2 is equal to V3 is equal to 0.88573. Now the whole TV diagram is level on T, P and P. Now we know that we have two formulas. V2 is equal to Vf plus x3 Vg minus Vf. This is V3, sorry. And U3 is equal to Uf plus x3 Ug minus Uf. So from this formula we will find x3, and from this formula we will find U3. So first we find from the table Uf, Ug, Vf, Vg and Uf and Ug. So from, and point 3 pressure is 100 kilopascal. So from saturated steam table at pressure is equal to 100 kilopascal, find Vf, Vg and Uf and Ug. So at 100 kilopascal, this is pressure of 100 kilopascal. This is, so here this is Vf 0.001043, 0.001043 meter cube per kg, and Vg is equal to, this is Vg 1.69400, 1.69400 meter cube per kg, and Uf is equal to, this is Uf 417.33, 417.33 kilojoule per kg, and Ug is equal to, this is Ug 2506.06, 2506.06 kilojoule per. Now we can easily find x3 and then U3. So now we know that V is equal to Vf plus x3 Vg minus Vf. So rearrange this equation and find x3. x3 is equal to V minus Vf divided by Vg minus Vf, which is equal to, V is basically V3. This is basically V3. So V3 is 0.88573, 0.88573 minus Uf. So Uf is equal to, Vf is equal to 0.001043, and unit is meter cube per kg, divided by Vg is 1.69400 minus Vf is 0.001043 meter cube per kg. So per kg, meter cube per kg will be cancelled, and x3 is equal to, x3 is equal to 0.522569, 0.522569, no unit, x3 is unitless. Now we know that U is equal to Uf, U3 is equal to Uf plus x3 Ug minus Uf. So U3 is equal to, Uf is equal to 417.33 kilojoule per kg plus x3 is 0.522569 and Ug minus Uf. So Ug is equal to 2506.06, 2506.06 minus 417.33 kilojoule per kg. So U3 is equal to 1508.83 kilojoule per kg. Now U3 minus U1 is required. Now U3 del U is equal to U3 minus U1, which is equal to U3 is 1508.83 kilojoule per kg and U1 is 2808.55 kilojoule per kg. So del U is equal to minus 1299.72 kilojoule per kg. This is almost equal to minus 1300 kilojoule per kg. And negative sign means the internal energy is decreases. Negative sign means that internal energy decreases, because there is cooling in the problem. In the statement there is cooling involved, it means that internal energy decreases. And this is the end of the problem. And for more problem, please like and subscribe my YouTube channel and share with your friends. Thank you.